Hello, my name is Martin Hendry and I'm Professor of Astrophysics at the University of Glasgow, where I'm also the head of the School of Physics and Astronomy. I think my science superhero probably has to be Albert Einstein. He's one of the most famous scientists there's ever been, and I think what's remarkable about him to me is that he was great at asking the kinds of questions that other people probably thought afterwards, oh, why didn't I think in that? He would take some ideas that people, I guess, kind of took for granted, and he would just re-evaluate them. He would try and approach them from a different point of view, and it led him to some really remarkable discoveries about the nature of space and time, what we call his theory of relativity. Much of that came out of Einstein just knowing the right questions to ask about our universe. The wormholes that you see in Interstellar are a very good example of where the science that underpins Einstein's relativity is in some ways really quite weird, and it seems to run contrary to our common sense and our everyday experience. Now, wormholes are in principle possible, they're theoretically possible. The real problem is that according to the theory, they should be incredibly small. I mean, so small that even an atom would be enormous compared with a wormhole. So I think the real challenge, and the one that they get around in Interstellar, is making a wormhole big enough that you could fit a spaceship through it to keep the wormhole open and stable for long enough to actually use it as a way to travel between the stars. So maybe that's the part which in Interstellar is a bit speculative, a bit beyond the bounds of what we would regard as real science. But you know, if you look at some of the ideas we currently accept within science, and even go back a few hundred years to the time of someone like Isaac Newton, then those ideas would have looked equally incredible to him. So who's to say, maybe somewhere down the line, somewhere in the future, we might be able to make wormholes ourselves. This is a really good question. I think when you first approach the idea of an expanding universe, it's very hard to grasp what that concept means. And we often use a metaphor to explain the expansion of the universe that involves an expanding balloon. And even that can be a little misleading because we can see the balloon expand. We sit outside of the surface of the balloon. So indeed, the balloon is expanding into something. It's expanding into the three-dimensional space that we belong to. But the remarkable thing about our universe is that we believe it's expanding, but it doesn't necessarily have to be expanding into anything. It could be that our universe is all the space there is, and yet it's still expanding. Now that's a very deep philosophical idea to get your head round. But interestingly, it could also be that our universe is expanding in a kind of higher dimensional space of extra dimensions that we don't normally see, we don't visualize or experience. But those extra dimensions, if they existed, could help us to understand some of the deep physical properties of our universe, to do with, for example, the kinds of particles you get in our universe, that there could be certain advantages, certain symmetries that only emerge from a universe with perhaps even as many as 19 or 26 dimensions. So the question of, is the universe expanding into those higher dimensions? It's kind of an open one, but it certainly isn't the case that there needs to be extra dimensions to have an expanding universe.
I can work with microsystems and small things, not just building bridges.